Welcome to another problem session. So this is a problem from JEE 2024. We are doing paper 2 now, and it's question 3. So really, either you know Moseley's law or you don't. If you don't know, then you won't be able to figure out on this part. So it comes from Moseley's, and this was found experimentally, but you can even study theoretically. So what's happening is you have a metal, and this is a shell diagram of metal. So this is the K shell, this is the L shell, this is the M shell, this is the N shell, etc. So, and this is where the nucleus is. Okay, so you this has 2 electrons. So if you send some kind of beam with very high energy, it's going to knock out all kinds of things. But if it knocks off one of these, then all these electrons over here, they're going to see only, if this is Z, then they're going to see Z minus 1. So like L shell electrons will have effective Z will be Z minus 1. So if an electron is in the this shell, it has to fall. This electron has to fall to K shell, and this energy, so EL minus EK, this energy has to come out in as a photon, and this is actually energy is X-ray, and this is called K alpha line in the X-ray spectrum. X-ray spectrum will be like a X-ray spectrum, continuous. Looks like my pen has got a problem. Okay, so I changed the battery now, so hopefully it's going to fine. So if you look at intensity of X-rays that come out when you bombard, like they're saying, it's like you have a target and you send an electron beam, and of course the a photon will come out and the electron will come out too. So this process, the intensity of these gamma rays will kind of go I think go like this. So this like a K alpha and this lambda, K alpha, K beta, K gamma, etc. So this is the lowest energy. K alpha is the lowest energy. So this one, from if an electron comes from L to the K, this is K alpha. If it's come from M to fill in the K, that will be K beta. From N it comes, that's going to be K gamma, etc. If the electron that got knocked out, if this electron got knocked out, then you'll have from M to the L, N to the L, those will be these lines, like A, L alpha, L beta lines, these lines. Okay, so Moseley found that that these frequency that came out frequency of the alpha line that came out was proportional to z minus 1 alpha square. And kind of make perfect sense. If you kicked out the innermost one of the two electrons, then you have only one electron shielding. One electron is shielding, so the else electron will have effective z minus 1. And you can understand this because from the energy of this fall, if the L shell electron energy, so where is the delta? Yeah, if you look at this electron EL minus, if you work it out using hydrogen atom, so this is not like it's going to be not hydrogen atom, it's going to be hydrogen like atom model with the z there, then this will be z minus 1 square, and there will be some factors here of units of energy. Okay, so if that's the case, then you can say that lambda alpha will be 1 over z minus 1 square. So what's given here is lambda alpha over lambda cutoff, and cutoff would be a little different for different metals, but these z being close to each other, we'll say they are same. So lambda alpha or lambda cutoff, when z equals to 46, that's set to be 2. Okay, and so we're supposed to figure out lambda over lambda cutoff when z equals to 41. So you can say what I'll do is like, okay, I want to find this. So this guy is proportional to z minus 1 minus 2 because of this, and so this is proportional to 1 over 45 square, and this guy is proportional to 1 over z minus 1 square, so that's equal to 1 over 40 square. Now take a ratio of this with that, and so you have a lambda alpha over, so all these constants here, constant to kill the constants, you're gonna say lambda alpha over lambda cutoff when z equals to 40 equals to lambda alpha over lambda cutoff z equals to 46 times 45 square 40 square. So if we take a ratio, cancel all the constant. So this is 2. This opposite, I inverted it, 45 square, because this can invert over there, and 40 square. So this is 2 times 9 square over 8 square, and so 81 over 32. So I've put in calculator. You can already see, don't have to calculate it. This would be way more than any of these. This is going to be this number. This is going to be 2.53. Don't even need the calculator. You can just guess from there. It's going to be 2.5, right? More than 2.5. Okay, so this is kind of a problem in which you know some atomic physics. This is more like a chemistry problem. Physics people usually don't really deal with this kind of stuff that much. Okay, I'll see you another video. Bye.